Clear when it's. Oh, well, look live.
Oh, great. All right, welcome. My name is Brian Gallagher from EMC, and whether you are live with us today or whether you're watching this recorded, this will be available for viewing at a date. But we'd like to thank you for taking the time today to spend with us. We're here at the EMC Dojo in Cambridge, Massachusetts. Obviously, we'd love to have any of you that are watching come and visit us at Cambridge. At any juncture, the doors are open. Just come on in, and we'd love to show you what we're doing here at EMC. But not to delay any longer, I would like to introduce Nadeep Levine. Nadeep is the CTO of the Cloud Platform team and also a member of the technical staff, reporting into John Rose for the office of the CTO. And you're going to learn about Unik kernels and some advancements that Nadeep and her team made in the space of Unik kernels, specifically around Project Unik. Thanks, Nadeep.
Hi, everybody. I think we should start. Let's start. We're going to share today what we're doing. And first, let's start talking about the motivation for right? So, when we looked at this stack that today that people use, they will say that the hardware and the lower, hardware drivers, the iPhone, then you have the visual. Then you have the OS character, the OS unit. On top of it, you have the program runtime, the shared library, the language runtime, and application and your application. And when we look at all of this, we try to remember what is the motivation for this stuff? What are we really trying to do? And what we understood is that our aim is to run a single application with a single user on a single server. And if you're looking at the stack, there's quite a lot of redundancy, right? For instance, if you're looking at isolation, you have isolation on the hardware, you have isolation on the hypervisor, separating the units. You have a separation of the operating system supply, you don't Docker is doing kind of dependency, separate between the application, and then you have also separation between the user and the application. So all of this, there's a lot of redundancies. And the question is why it's so complicated? Why do we need this? And what we understood is that the main reason is the complexity that is in the kernel itself. If you're looking at the kernel, one of the main functionality of the kernel is to protect. This is what it's doing. So it can protect applications more quickly. You separate user to user. You can protect application from user. And that was really, really makes sense when we were sharing computer on the 50 and 60. It's a funky computer, very, very expensive, and you needed to share it with other users and other applications. But today, that's not really what we do. They were running one application on a single server, single user. So not really the most efficient. If you're looking at other things like the microservices architecture, we can see that there is a lot of duplication, right? For instance, Linux did a lot of the stuff for us, like LCD, and now we're doing exactly the same thing with a distributed function like LCD. Right? If you're looking at the kernel itself, so there is a lot of unnecessary drivers in the kernel. We still using floppy. We have a floppy driver, even though we don't have a floppy driver in this itself. We also have a USB when we're running on the cloud, even though you can really get to the machine, you still have USB driver and so on. So a lot of unnecessary, we can buy to if you're looking at, besides all the model of Apple today, so if I'm running on a Fedora and I'm doing YAML, I'm running on Ubuntu and I'm doing GetUp, there is a lot of unnecessary components that get downloaded. So again, a lot of inefficiency on this stuff. And if you're looking at the security, which is something that is always interesting to see, there is a very, very large attack surface to Linux because there is a lot of conflict. A lot of probably unnecessary, right? There is a lot of exposure that target Linux, um, which is a little bit harder to target hypervisor because it's usually time different. Um, and the other thing is that the microservices architecture that we're doing today, we are sharing a lot of stuff. We're sharing kernel, memory, classes, hardware. And the only thing that basically make it kind of like safe is some kernel extension like C2. So very, very hard to predict. Um, so how did we get it, right? Why it's so artificial? And that's a its evolution, right? So we started with the computer mainframe, we moved all the way to the private computer, then we went all the way until the Android today. And what basically common with all of those is that we Unix supported us all the way. When Unix was there, right? We supported all the functionality, all the way from mainframe to the end. Um, what can Linux can run on? Anything. What can run on Linux? Anything. I can theoretically take right now the last computer distro, put it out of the box on my Pentium 1 that I had 10 years ago, and just like this, right? Basically, out of the box supporting it. This is exactly the trade that we need to do as a community, right? We basically create efficiency versus compatibility, and we chose compatibility, which is totally fine. But we make it work, right? Because today Google and Facebook of the world are running an hyperscale applications in a very great data centers in a very efficient way. But now it's time to make it right. We can make it faster, we can make it right up. This is why I want to introduce you to Unik. So what is Unik? Before we get into what is Unik, I just wanted to kind of like focus again on the Linux kernel to understand how complicated it is. If you're looking at the slide, what you can see is that there is a lot of language that the kernel is using, right? Tons of language technology that one need to know if you really want to be a contributor to the Linux kernel. Because there's not a lot of people probably in the world that can actually sit down and maintain the Linux. It's very complicated. If we're looking at the size of the Linux kernel, if we're talking about the size of application, a small application I estimated as a 10K lines of code. We're looking at medium to large application, it's probably around 100 K lines of code. And we're talking about the huge application, I will estimate like 1 million. We're looking at the Linux kernel, there is 22 million lines, right? 22 million of lines of code. This is like huge. We're looking at the Debian distro. We're talking about 490 million lines. This is like huge, huge, huge amount of lines. Very complicated, probably very hard to maintain. Reasonable. If you're looking at the ratio between the kernel line of code and the Debian, you can see that most of them is in the Debian, and that's exactly what operators companies like CoreOS and other distros are trying to do to it to reduce the line of code, but none of them is touching the kernel. Okay? So let's look at the traditional approach. What's going on today? So today you have the kernel, you have all the libraries, and you have the application. You using it no matter which application you use. And every application you still have on your computer all those libraries in here. What Unicron is doing is basically taking only what's needed, what your application will need. So only the white. So you don't need the part that you don't need for the kernel, the full part is not going to be included in this machine. The libraries that are not being used are not going to be included on your machine. Only what you really, really need to run your application. which means that different Unik kernels for different applications, right? Okay, so now just a little bit knowledge about Unik kernel itself. There's two types of Unik kernel kernels. One of them is the what's called language specific. So in this group, you have quite a lot, like OS, for instance, that was developed by the Unik kernel system just acquired by at the beginning of the Docker. Um, that means that if you want to run, so it's much more performance because it's specifically built specific to this language. But you have to write this language. So for instance, if you're running Garage OS, you have to run Kama. It's like one-to-one, you have to do it. Which means that if you have your whole application and you didn't choose to write the Kama, you cannot run it. The other term is the POSIX client. So POSIX is basically the API of the operating system, and if you supporting the POSIX API, you basically can run a lot of very popular code application, like for instance C++, C, and Node.js, and Python, and Ruby. So what did we do? So when I looked at this, I said, this is the right architecture. Why it's not more Docker? Why not everybody position? And when I understood, it's exactly what Docker understood in the Linux container environment. It's very hard to work. You need to be at a very low level of engineering. It's not something that's very popular. So what we decided to do is exactly what Docker did to this container. What we did, we created a command line to the REST API for Unik. So what is Unik? Unik is basically a tool within Go that is compiling and running Go Unik. So you supply us your application and then show it in the workflow. And we're creating the Unik kernel specific for your application. So you can actually run it on a cloud provider that we're supporting, and you can easily add more, and on any embedded device that you want. And actually, you can also run it on So what do you do when you want to use Unik? You basically spin Unik daemon, that install the daemon, make sure that everything is up, and then you can just build the Unik kernel. If you want, you can attach volume to it, and then eventually what you're doing is very simple. So this is, for my opinion, is the most important slide in the show. The way we architected Unik is that we decided that it will be non-opinion. And the reason is because this market is very new. We don't know what really is going to catch. We don't know what this type of unicorn is going to catch. Catch. We don't know what where people will want to run unicorn. We can estimate, but we don't really know. And therefore, we decided to just do a very generic platform that you can add easily support to what you have. So the unicorn that we support today are from kernel, OSB to 101 Java, and Camel. The cloud provider that coming today is support, and we added, you can add constantly, and we're working on it constantly. It's AWS. You can run locally on your machine with VirtualBox. Soon we're going to release the QEMU, which will give us KVM as well. You can run it on EXSI, on vCenter, and vSphere, and you can also run it on Flutter. And what we're working right now is also to run it on OpenStack. So that's that. And besides that, we're also supporting the two processors architecture, the Intel one and the ARM one. And I will leverage more a little bit about why it's so important. So again, the power of Unik, for my opinion, is that make it very easy to use, but you can easily, because the way we architect it, add support for more often. And because we wanted to make it very easy for you to share your Unik kernel and to use the one that already been built in the community. We are working today to do on building a Unik hub, and so it's going to come soon. And the idea with that is that, first of all, not everybody, not always the one who building the Unik kernel is the one that will run it. So what we want is that if someone is building the Unik kernel and someone else wants to run it, it will be very easy for them to communicate. So again, it's coming soon, and we will announce it. Okay, so we did that, and then we said, let's see what is already in the community. What we noticed is that we know that Docker is very popular API in the community. We really buy into it and really like it. So what's very important to us to do is basically to make sure that that Unik know how to talk Docker API. So people who already adopt Docker API and running it in the infrastructure will not need to run a new API. So what we did, we teach Unik to speak Docker API, and that's exactly what we did. So you can run to the command like you need to target the daemon of Unik, and then you can basically use the -h flag with Docker, and you can just run a command like images, like ps, like run, just like the work. So so Docker and Unik will create your Unik kernel container, but they're not going to maintain it. It means that if right now you want to run 3 instances of this Unik kernel, and one of them is dead, Unik will not tell you about it. So that's why we decided to leverage the Kubernetes framework. What's special about Kubernetes is besides a lot of the other components that it's giving us, like networking and services, what is very strong is that it's also, you define the state of how your application should look, how much instances you want, and it's make sure to keep it the same number all the time, right? So if you're looking at before Kubernetes, we supported Docker and Rocket, and now it's also support Unik. So you can run basically create a pod, run Unik kernel inside. If one of the Unik kernel will die, we'll make sure to bring Unik. But we didn't stop there because it was very, very important to us to give the developer the best experience. And we feel that the best platform as a service to do that is Cloud Foundry. So that's why we integrated with Cloud Foundry. So today, when you're running Cloud Foundry, if you're pushing application, you can push it to the old. If you're not writing anything, you will push it to the old architecture of Cloud Foundry. If you using the command enable Diego, you're going to run it on the new architecture of Cloud Foundry, which is Diego. And now you can also do enable Unik, and you can run it as a Unik. So basically, you can run the same code one time as a microservices, and the other end container, and the other one as a Unik. So now, let's see if we can.
Okay.
Okay. So let's see how it's working.
Flip your mic.
Can you see that?
Can you see it back there?
Can you see that? So let's see how it works. Okay, let's see a very, very simple game. So the first thing I will do is I'm just going to use the command line. If you're doing Unik, you're getting all the functionality of what you can do. You can list the Unik kernel, so let's start with that. So if I will do Unik queue, I'm basically listing the Unik kernel that's running, that I already built before. If you're looking right now, I already built before a Unik demo Unik kernel, and you can see it here. If you will do Unik PS, you'll see that basically this is the listing all the Unik kernel that's running right now, and as you see, I don't have any running. So what we'll do now is let's run one. Okay, so Unik run with the name of the Unik kernel. You will see that set will allow Unik kernel running in the cloud. So this is specifically running on AWS. What we'll do now, let's go and do PS. Let's see if it's already up. And yeah, we can see that it's already up. So now what we're going to do, let's take the public IP of the Unik kernel. Just go see if it's actually working. We're going here, putting it 40,000. And you can see that we have Unik kernel running on AWS, right? It's a static website, really good code. Okay, so that was easy. Now let's see how complicated it is to actually build one. So, then to build one, the only thing that I'm doing is Unik. You can We'll give it a name. And basically boom. So that will take a few minutes. While we're doing that, what I'm going to show you is the integration between the platform. So I have a command line here. So I have a command line here, and I will try to do this. A problem with the network, so I will work with that 1 second, and let me show you the demo of the internet. Until that here. So what we understood when we built Unik is that people will argue if Unik kernel is actually the right use in the cloud. It's still new, and there is quite a lot of very mature stuff that's running already. So what we understand is that the perfect function features of the Unik kernel are perfect fit for Internet of Things because it's very small in footprint, which is very important in Internet of Things. It's very secure because the surface of attack is very small. And another thing is that it's very performant because it's basically running on there's not a lot of line to do it. So therefore, what we decided is to show you the vision, and the vision is Internet of Things. So what we did, we basically decided to support ARM because this is the processor that most of the Internet of embedded devices is using. And what we did, we basically run Unik kernel, run kernel specifically on Raspberry Pi. So this is how we did it, and I think it's really cool because no one did that before. So it's very cool. And what we did, what I will show you right now is a demo. In each demo, what I will do, I will basically ask Unik to make me a toast. So let's do this quick.
Yeah.
Probably because I need the network to connect to it.
You need what?
I need to be a specific network to connect to this.
Wait, I thought you just like use the camera.
No, not like.
There you go.
No.
Okay. So yeah, question. So you're oh, you're right. Oh, but this one is on. Hey, wait a minute. Yeah. Let's set this one up. Okay.
So, okay, so what we're going to do right now is going to run a small application that we wrote. So as you see, it's very small application. It's not doing much. Okay. So what we're doing right now, we're going to what we have here is a Raspberry Pi connected to a switch that connected to a toaster. What we're going to do right now, we will take toast, right, and put it inside the toaster, right? So the toaster is not working. It's basically okay. And what we're doing right now, we're going to power on the Raspberry Pi. And click on the button. Hopefully, what will happen right now is that Unik will tell basically the Raspberry Pi we're going to boot in U-boot. We'll talk to Unik, we'll get the Unik kernel, we'll run it on the Raspberry Pi, and we'll click on this. Flip the toaster. so what you see is right now the switch is power. This is power, and we have basically unit rigging on this dose. So let me continue doing that. And while we're doing that, let's go back to the demo. So let's switch and go back. So I need back the. One second. So right now I'm clicking back to the demo itself. Let's see if it's actually built as a Unik or not. Okay. You want me to go to this one?
Wait, what? Huh?
Oh, mine.
Oh, you're on. Yeah, you have to get off the corporate network.
Yeah, that's right. Do you want me to show it here again?
No, it's fine because I have the camera turned so it's showing the whole screen.
Okay. So now we see that actually we build a new Unik kernel. If we're going to go here and do Unik view, you see that we are supposed to have the you have right now the live that we just created. So it's, again, it's a very simple Unik kernel if I want I can just run it, right? Let's go back to the Cloud Foundry and see if the Bosch is alive again. It will be alive, and it's alive right now. Okay, cool. So if I'm doing C app, you see that basically there's no any application that I'm running right now. I don't have instance. So now I know that to build a Unik kernel, the only thing that I need to do C app. And when I'm doing the CF push, I'm doing no start and I'm pushing it to Unik. So that means that actually I'm going to build a Unik kernel instead of run my application. Okay. Yeah. Network is good again. So it will start running and we'll see it doing right now. In the meantime, okay. That will take us a little bit time. What? Okay, we started just doing it right now because it didn't start. Let's see again what's going on in Unik if we're doing the NCS. That running, by the way, the thing's not working here. We need quite a lot of smell. So, continue. So we'll do right now 1 second is here. Here. For this one. Do this. So now it's working.
There's some network concrete.
Yeah, there was some problem with the network.
Yeah.
So now it's basically taking the application, it's pushing it as a build pack, it's building the Unik kernel, and it's making sure that That's exactly what you see, the build path that we created, and it's going to create it too. For the meantime, the dust actually finished, so we make finished to make the toast.
I smell toast.
Yeah, it's very, very burnt. That's good.
Any bacon, egg, and cheese with that?
So that will be it
Next
for a second. And do you have any questions for the meantime? Can I ask? Okay, that's fine. So we'll just see how clock partner is.
Any questions on the line?
Yeah.
You must get this a lot, but any plans for Python support?
It's funny
You
enough,
must get
it's
this a lot,
probably will
but
be
any
by,
plans for Python support?
yeah, actually, we have been going to probably release it by Monday, Tuesday, but we just Monday,
We're working on it.
we're working on it. Monday, Tuesday, probably. Right there.
You're not joking, right? I think you actually expect.
No.
Yeah, okay, that's what I thought.
Yeah. No, so we already have support right now, as I said. So we have support in Node.js, in C, C++, and a lot of other language. So while it's building it, I just wanted to basically reference you to the website because that's it. So what you can see is actually that we open source it, so it's out there, and everybody can look at it and contribute. And we really, really want to have a community around it. So we open that, you will see that this is a repository, and you can go to the Unik. So as you see, you released it 2 weeks ago, around 2 weeks ago. It's there. There is like already started to emerge quite nice community around it. It's very easy to install, very easy to play with. Really, like just do it. We're adding feature constantly, so go and follow us in Project Unik and EMC Dojo because we're constantly adding and releasing feature. There is all the explanation of how it's works, what we're supporting, all in the website. So please go and look at it and see what's going on with it. Oh, so it's done. So now we will do here apps. We probably so one. Yeah, we're going to do is going to scale it. Yeah. So basically, we need the application and scale it to 3 instances. Let's go right now to Unik command line. We didn't build it. Yeah, that's the example. So yeah, we have some network problems, but for some reason it's not. You start.
Are you looking right target?
Let's start. Let's just start. September. And the network 2. Yeah. I don't know. I don't really know.
The URL work.
Yeah, I didn't create it.
I think you targeted at the wrong manufacturer.
I need to press one.
Yep.
And we have some, the network already killed this. So we are already.
Oh, wait, now it's running.
Okay. The network is a disaster. See now it's exploded. Yeah, now it is. Yeah. The network did something like that. Yeah, so we audio them, I guess. Well, I guess we will audio them.
We can record it
The
later.
network.
Unique target.
Record it later, add it to the
This
video.
is the right one. to write on it for sure. Well, so we all do a demo, I guess. I don't know, the network just really messed it up.
Well, we made toast. So.
You made toast, yeah.
Yeah, it does. Interesting, yeah, happening, we'll figure it out. Okay, sorry about that. Is there any question? Except white one question? Because I have some question.
Oh, wait.
Mike?
Yeah.
So my question is, what is the difference between Unik and Docker? If somebody doesn't care about fat kernel, fat surface attack, or security,
If you don't
What
mind, if it doesn't mind, it's not going, you can use Docker, and it shouldn't be any different. Like, I mean, what we did for Unik, we really believe in the architecture of Unik. So what we did is basically make it very, very easy to work, right? Exactly like Docker did to Linux container. But if you don't mind about security, you don't care that you have a very inefficient stack, you can continue using Docker. By the way, we're assuming that anyway people will continue doing it. We're not expecting that everything will be Unik. We just wanted to make, first of all, we do think that in Internet of Things, that will be the way to do it, because it's perfect features to that. And we do believe that that eventually, we hope that when the Unik kernel will mature, more and more application will run on the Unik kernel, like specifically like application in the NF3 world, right? The telco that really makes sense for them to run like that. So
So is it like people, while they are making their application, figuring out what is the smallest footprint for their application, continuing on and once we figured out this thing I can do, that thing I can do, that thing is now solid, then we will do it.
yeah, so basically they can go on and build it on Docker, like they can try to put Unik, and it doesn't really matter. They did debugging, they making the application ready, and then they can choose if they want to run it on Unik or they want to run in containers. And yeah, I mean, the cool thing about Unik is that we added a lot of features that, for my opinion, are very important. Like, for instance, logs, so you can go and do unique logs, and basically, and go unique demo. And you're getting basically the logs. What we're working right now is also to add a debugger, automate the debugger one. There is a trend that people think that Unik are not debuggable. That's actually not true. This is the way we build Unik. We had to debug it, right? This is the way we did that. So what we're working right now is to automate it that way, that you can just attach the debugger and check the application while it's running on the Unik kernel. So the way to debug it. So again, it's a choice of, this is the application that I want to run, and then you need to choose which provider you want to run it on, right? Or do you want to run it on bare metal, or what do you want to do? And then the question is, do you want to run it on Unik kernels, or which is much more efficient, or do you want to run it on a container which will work there, right? So, makes sense? Yeah. So again, sorry that the demo guy wasn't with us, but we will record it and we will send it. Awesome.
The demo gods must be appeased. All right.
Yeah. Yes.
Does the way you handle dependent services change in this model versus a container model? Like if you've got database, that sort of thing?
No, so actually, the best, it can be, the way we wanted people to do it, the most efficient way is to make it immutable, which means that it basically will be the microservice architecture. That will be the best. But theoretically, it's a VM to everything, right? You can run database on it, you can run all application, lump stuff, whatever you want, because in the end of the day, it's basically a VM, right? So you can run all those. Okay, cool. I'm good?
Thank you.
Thanks.
All right. Brings our meeting to a close. I guess we have food and drinks and other stuff.
Yeah.
So, beer. Shut off the.
So, I wanted to throw some questions. First, comparison, Unik kernel versus container.
Nope.